Все, так, с первым докладом пока техническая у нас связь не установлена, специалисты работают. Тогда сейчас у нас будет третий доклад.
So we don't have any connection with the first speaker, so we get down to the third presentation. It will be delivered by Mr. Sergey Atrushkevich, Chief Designer of Novinka Company Feed Group. It's me, it's myself.
Так, ну снова здравствуйте, представляться больше не буду. Я вам расскажу о нашем изделии, которое уже мы как бы разработали 2 года назад, сейчас его продвигаем, усовершенствуем.
Defect detector we developed it 2 years ago, now we are improving it. So this is the defect detector for the CT tubular. You could see an example sample at the entrance to the room.
Первое, что делает, это закрывает пункт 10.30 правил безопасности нефтегазовой отрасли.
So this covers 10.30 item of the security rules in the oil and gas sector that such units should be equipped with the flow detection devices. So this device was developed for this very purpose. It measures the wall thickness, trying to detect the thinning, and measures a number of other parameters. So it detects holes and punches, cracks, dents. Besides that, it measures the diameter and calculates the ovality. This device works from 31.75 to 58 millimeter. It operates from -40 to +50 degrees. You can see the main block of this device, the measuring block. The system is based on a magnet measuring, so it magnetizes the tubular, and there are sensors that are reading this magnet field created on the tubular surface. If there are defects or dents, the magnet field changes and it reads these changes, identifying the wall thickness. The previous ones worked with 38, 50, and 44, so we added one more diameter here, 31.75. And we work to produce such devices for higher diameters. And we have a possibility of joining all the CT diameters into one detection device, but it's not reasonable. Then the detection device becomes very heavy and large. So for ourselves, we decided that this device is going to be working with the CTs from 31 to 50, and the second one from 50 to 73 millimeters. So this device is installed on a CT and is fixed.
If
it tears up, in order to avoid any breakage, the signal will be sent to a relay that cuts down the power supply. What are the peculiarities of this device? This system is installed on the 2 spring rolls anchors, so it's not a rigid anchoring. So the main advantage is that the rolls will wear out. Whatever the rolls are, still they will wear out, since in the magnet system, from the distance from the tubular to sensors affects accuracy. If we put on the rigid rolls, they will wear out and the distance will increase and we need to replace them. But this system with the rolls instead of installed on springs, suspended rolls, regardless their wear and tear. The suspension or spring system pushes the rolls up to reduce this distance, and they also take into account for the vibrations on the CT, so this block is centered in a proper position. There are motion sensors as well, odometers, measuring the length of the tubular. For floor detection, all these diameters and defects should be linked to the length of the tubular. So we have a double system.
Убирает проскальзывание. Во-первых, у нас стоят ролики.
It avoids sliding of the tubular. So we have rolls with special slots that take all of the mud, and we have two odometers, and we reduce our dependency on the tubular slips and slides inside. So this is a photo for the CD 38 millimeter in diameter. There is no point in pulling the pipe through the defectoscope. So we just open it and install the pipe.
Общий комплект поставки, значит, если так, включает в себя непосредственно измерительный блок, поводок.
So the supply kit includes the measuring block, the wind, and the display device. We supply a laptop where you can see all the information. This is the simplest option. In the more expensive option, there is a panel computer that is installed on the panel of the CT unit. So it depends on the wishes of our consumers. We can provide different configurations. As I mentioned, this block is meant for 4 tubular diameters. To move from one diameter to another one, what do you need? So it's linked to the control diameter that the client tells us. So you need to order additional blocks, additional sensor blocks for new diameters, and the magnetic conductors. So these are the elements in red that you need to replace, and the blue ones are the elements that need to be reset for a different tubular diameter. So this resetting is done during one day. So if you move from one diameter to another diameter, you're replacing some parts, and you can ensure transit in the system to a new diameter. So this is the test pipe that we use when producing our detection devices. So this is the tubular with different defects. We pull it through the detection device to fine tune it, and you see how the information is shown on the screen. We also developed a special software for this device. This is fully in-house. We started developing this software in 2018, and there were several versions. If you have a look at the beginning and now, we have quite considerable differences in this software. So this is the geometry, vibration, thickness, as a text and graphs. It archives all the data. The data is recorded on SSD, and later on you can analyze it. There's visual and sound signaling system. So if this defect, we might set the maximum parameters. If it is exceeded, you will receive a signal. And for the operator not to miss it, the sound signaling will last until the operator presses a button, and this is recorded in a special file. So if some unprecedented event occurs, you will be able to see the history. Data shaving to the block itself is one of the options. Why do we need this? We had a situation at the very beginning when the block was operational, but we had problems with cable and the information was not coming to the computer. In order to avoid this situation, in this case, we introduced one more memory block into the device itself. So if data is not coming to your computer, the data will be recorded on the device itself, and then you will be able to take this information later on. There are various indicators, defectograms, depth, reports, etc. So these are the main functions of the software. For the defectoscope to work correctly, you need to calibrate it. Calibration is done when we supply it to our clients. So they supply us with a set of tubulars. If you need 30-millimeter diameter, you submit us with the pipes to calibrate it. So calibration is done, and then the detection device is installed on the reel itself, and if you don't change the tubular, then you do calibration every 6 months. If you change the diameters, then you need to do calibration every time you change the diameter of the pipe. Calibration itself takes 15-20 minutes max. So you can have a look at the photos. These are photos of our experimental works and tests conducted, detection of holes, and how these holes were depicted on the charts. So we developed our software, as I mentioned. It's the level of defect detection in particular. Over the recent years, we accumulated a lot of experience, so we received a lot of information and defectograms. And if we take this magnetic detection method, it identifies the change in magnetic field. And at first stages, if you have 1 millimeter of additional material and 1 millimeter of removed material, it showed in the same way because the volume of metal was the same. Now we fine-tuned it, and all the defects can be divided into 3 groups, like small cracks, then small fragments like shavings, and the scratches outside, asymmetric scratches on the pipe surface. And the software is built in such a way that it detects this difference, and when it sees a small volume loss of the material or a crack, it is depicted in red and green by the edges. If there's sticking of some material, it is marked in green in the middle and red on the edges. If we have scratches, asymmetric scratches, and then green and red colors are used to depict the scratch. And this system can transmit information to third parties. If we have a defectoscope that is measuring the wall thickness and ovality, this information might be transmitted to SKR and the diagram of load diagram can be built in a real time because we track data in real time. In parallel to this, we have been improving our device. We've increased the number of diameters that it can accommodate. We improved accuracy by 10–15%. We simplified the operation. What are next steps that we plan? Because the hardware is quite good, we believe. There will be some development of this hardware. We have one detection device in the north. We replaced rolls only once in a half year or in a year. So we believe that all the subsequent development will be related to improvements in software in order to simplify the processing and analysis of the information. That's all from my side. So you can check the hardware outside of the room. You can touch it and feel it. Should you have any questions, I am ready to answer them right now or during the break. Thank you, Sergey. Thank you for a very interesting presentation. I have the following question.
Интересует то, что сейчас ваши дефектоскопы уже эксплуатируются у нескольких заказчиков.
Your detection devices are in operation already.
Визуальную информацию, которую показывает дефектоскоп, это доступно оператору колтюбинговой установки?
Who reads the information? The CT operator, or shall it be a separate specialist who can read these charts and diagrams? So usually it's a separate specialist. The CT operator can have a look at this detection device screen if necessary. When some unprecedented event occurs, some emergency occurs, if we take this sample, you don't need to enter any commands. It's all done automatically. So initially you had to switch on the detection device, upload the file. Now you don't need to do this. You just switch on the power and the file is uploaded automatically. Software starts automatically. So. And in the software you can set the thresholds for signaling for certain defects. We decided that up to 80 magnet units, these are non-dangerous defects. So dangerous defects start from 120 units, but the client itself can change these thresholds. If they have this defect, the signal will come. The signaling system will be actuated. So the operator deals with the CT running in whole, and another specialist will then analyze the defects. No more questions? Thank you. Thank you for your attention. And I was told that we have our first speaker connected, so we would like to give him the floor.
Да, вас слышно. У нас на связи Кичигин Анатолий Сергеевич, Packer Service.
So we have Anatoly Kichigin from Packer Service, integrated approach to addressing geological challenges. I would like to welcome all of you and I would like to thank those participants who are present physically or online. My name is Anatoly Kichigin. I am Business Development Director. So we again have an issue.
Вот вы проскочили. Так, ну попробуйте.
We don't hear you, or we hear you.
Слышно, коллеги? Вот сейчас слышно. Ну давайте попробуем дальше.
Давайте попробуем еще раз. Сегодня мы хотели бы с вами поделиться нашим опытом по работе в сложных.
We would like to share our experience about complicated geological conditions in our integrated service.
Несколько слов о компании Packer Service.
A few words about the Packer Service company. We have been operating for more than 14 years, more than 1,500 people working in the company. Currently, we are operating 24 CT fleets, 14 fracking fleets. We provide other services as well as EOR services, well completion, well servicing, etc. We also pay attention to the safety of works and the quality of works. So this is the East Misayakhskaya oil field. This is the Sanomanian part of the reservoir. They are quite vertical and abnormal coefficients in terms of the movability of this reservoir. So it's quite a challenging condition to produce oil from such reservoir. And this reservoir is low consolidated sandstone. So we managed to tackle all these challenges quite properly. There are different methods with the sand screen out and the production of fluid without sand screen out. So, and without sand screen out, we have chemical, physical, chemical, and mechanical ways of preventing sand produced to the surface. So the CTUs, so we use various methods for preventing sand screen out, the bottom hole area treatments. We use sleeves and collars, sliding sleeves, and the considerable part of works, this is normalizing the bottom hole. That CT allows us to clean out the well bore and put it into operation. But today we will talk about a little bit different thing. Historically, the development of this oil field can be divided into two phases. Phase one, this is well-known shallow wells, reservoirs with high sand content, and these are the challenges that we manage to tackle currently. However, there are other wells there. This is phase two with deeper reservoirs, 3,000 meters vertical depth. These are abnormally high pressures and the complicated mineralogical composition of the reservoir and of the rock at this phase. So we have abnormally high pressure, as I mentioned, complicated mineralogical composition, and in this case we have light oil, which is very good and very feasible from the economic viewpoint, but high temperature. We face high temperatures there in this reservoir and in this formation. Apart from the general challenges, we face the challenges of a specific well. So we needed to work at a horizontal well with a very difficult trajectory with the reservoir pressure of 490 bar. It's a deep well, around 5.5 kilometers, and the task was to activate fracking sleeves and restore the injectivity and to get the stable fluid inflow. So during drilling operation and running a liner, the liner didn't reach the target depth. So we also had to drill further and produce from this well. After analyzing geological data from this well, we remember that this is a very well that goes through the clay streaks, and the liner didn't reach the target depth. We took into account all the geological parameters, and we applied integrated frac and CT fleets on the well. You can see the activation of the fracking ports when it was not possible due to complications at the wellbore. We elaborated a set of measures to create additional perforation in the target interval where the production was possible. After sand jetting in the target interval, we achieved the following. The well became flushing, so we achieved record high yields for this well, and phase number 2 confirmed its potential because we managed to produce light oil that allowed us to continue working in this formation at phase 2. First of all, the success was possible due to the work of our geological services that managed to do proper geological analysis. I can say that we confirmed the good potential for this formation. We confirmed the complicated mineralogical composition of the formation that requires addressing geological challenges, and this requires integrated approach, CT and fracturing fleets. With the high involvement of the client and of the contractor. So we did sand jetting in abnormally high reservoir pressures. So I would like to extend acknowledgements to our companies, Research and Technical Center of Gazprom Neft and Package Service Company, for the possibility of sharing with you our experience with this integrated approach to tackling geological challenges. That's all from my side, and I stand ready to take your questions. Thank you. We have questions.
Анатолий, спасибо за доклад. Константин Бурдин, компания Schlumberger.
Thank you very much for the presentation. I'm Konstantin Burdin from Schlumberger. I have 2 short questions. Who is the manufacturer of the ports? Can you name? No, unfortunately, I cannot name it. The client did not allow us to disclose this information. We have different
Хорошо,
port
спасибо.
manufacturers,
Следующий вопрос.
foreign
После
ones and
проведения
Russian ones.
гидравлической перфорации
Okay,
наблюдался ли
next
вынос
question.
породы,
After
мы знаем,
sand
что
jetting,
Саяхи это одна
did
из
you observe
сложностей, то есть слабо
screen
цементируемых
out
пород.
and production of rock and sand? Because it's a problem in the non-cemented or these fragile collectors. Yes, phase one, as I mentioned, we observed sand production, but in this phase two, in this formation, we didn't observe any active sand production in wells. We observed some, but not considerable.
Еще вопросы есть?
Thank you. Any further questions?
Спасибо тогда за доклад, Анатолий Сергеевич.
Okay, thank you for your presentation. Good luck.
А мы переходим, значит, к следующему докладу, который предоставит нам воин Олег
We
Викторович.
would like to give the floor to Oleg Voin from Fracking Volga. He will be speaking about the development of the well hydraulic tractor. Good afternoon, distinguished colleagues. I'm glad to welcome you at the conference. I'm a representative of the Fracking Volga company. I would like to tell you about our development of the hydraulic tractor.
Что хочется сказать? Понятно, что заказчики в последнее время все чаще и чаще заставляют буровиков бурить стволы с протяженными горизонтальными стволами.
Ask us to drill long horizontal well bores, 1,500 meters. The more complicated the well is, the more complicated tasks we have to address with the use of CT. As my colleagues from FeedMash and Feed Group mentioned, we're moving towards larger and larger diameters of the CTs that we apply. The increase in the diameter tackles only some problems, but it cannot tackle all the problems that companies might have in long horizontal well bores. Tractor is one of the methods of tackling these problems. They can work in the longer horizontal well bores. With the help of tractors, you can do milling. It's a big problem in milling the frac ports in along horizontal well bores. Opening and closing the sliding ports. The previous speaker mentioned that they had problems in opening ports. Removal of the sand plugs, removal of packers, and open hole drilling. We analyzed the main existing tractors on the market. So these are electric with a hydraulic drive, fully hydraulic tractor, and electric with mechanical drive. These are the main types of tractors on the market. So on this slide, you can see the comparison table of different types of tractors. And we decided to develop a hydraulic tractor because it is a universal one, allowing to perform more types of operations compared with other tractors, and allowing to convey more load on the bottom hole. So we were producing and developing tractor from scratch because we didn't have any experience like this before. So the structure of the tractor itself, this is the scheme of the tractor, how it looks like. This is the mechanical pulling device, 76 millimeters in diameter. After that, we developed the hydraulic control system. At the second phase, we need to modernize our hydraulic system because the hydraulic system is not perfect and it requires some modernization. In parallel, we work on the electric control system that will be operational in parallel, and we also develop some attachment attachable equipment to these tractors.
тяговые усилия, которые создает наш трактор, ну, естественно, так как он
The pull
гидравлический, то
force
тяговые усилия у нас зависят
created by the
от того
tractor
давления, которое мы
and the pull
создаем
force, since
в
it's
ГКТ.
hydraulic, it
И,
depends on the
соответственно,
pressure
если
that
у нас
we
давление
create with the
50 атмосфер,
CT.
то тяговые
So
усилия
if the
773
pressure
килограмма.
is
Если
50
давление
bar,
350,
the
наше
pull
оборудование
force is
рассчитано до
700
350
kilograms, the
атмосфер,
pressure
то
is
мы можем создать
350
тяговые
bar.
усилия до
It's the
5,5
maximum
тонн.
we can create the pull force
Усилия
up to
регулируются с помощью
5.5 tons.
штуцеров, дросселей, и,
The
соответственно, с помощью них мы
force
можем
is
регулировать
created
подачу
by
жидкости, которая будет приходить на забой.
the drossels
Здесь
that
на снимке
control the
представлена
amount of fluid
система
reaching bottom hull.
удержания нашего трактора. С помощью таких систем удержания он
So this is the system to keep our
крепится
tractor
непосредственно к 114-миллиметровой эксплуатационной колонне.
and connected to
Здесь на видео
114
тестирование
millimeter
трактора
production
проходило
tubing.
2 дня назад.
So in this video you can see
Буквально
tractor
перед
tests
своим
run
выступлением
2 days ago.
собрали
Just before
трактор.
coming
Здесь как
here,
раз мы видим
we
гидравлическую
assembled
часть.
a tractor.
Гидравлическая часть
We can see the hydraulic
заходит в
part of
трубу
the tractor.
ГКТ, создается
The
избыточное
hydraulic
давление,
part goes
потом здесь мы
inside the
заглушили,
CT. We create
маслостанция создает давление.
overpressure.
Трактор заходит в трубу НКТ диаметром 114
Tractor
миллиметров.
goes
Здесь мы
into a
испытывали на видео
114 millimeter tubing.
тяговое усилие трактора, соответственно, при
So
создании
we
избыточного
tested the
давления
pull force.
мы смотрим,
When
какое тяговое
creating
усилие
overpressure,
создает
we can
трактор.
check the pulling force created by the tractor.
По характеристикам, если посмотреть основные, конечно,
As far as characteristics are concerned,
использованию тракторов, это компания Weltec. Ну и
Weltec is the leader in terms of the use of tractors.
нашего трактора, то мы разработали
And if we compare the specifications of our tractor is 76 millimeter, which is comparable to what the competitors have. The length of our tractor is 6 meters 41 centimeter. Probably with the update of the hydraulic drive, the length will change. It will be 6.5 max. We haven't yet developed the electric drive. The pull force at 350 bar of pressure, it's quite a large pressure, will not be using it, but at 300 bar, it's 4.6 tons. The weight is 176 kilos, and the fluid flow rate is
В чем оптимальное
500
применение
liters.
гидравлических тракторов? Ну, понятно, что в первую
Why
очередь
do we use the hydraulic tractors? First of all,
это то,
to
чем
flush
электрические
long
трактора
horizontal well
испытывают
bores.
большие сложности.
This is
Почему они испытывают электрические
what
трактора сложности?
the
Понятно, что
electric
шламоловитель можно
tractors
спускать,
have
но это
difficulties
затягивает
with,
работу, не
because
всегда
you
он может
might run
качественно
a
очистить забой скважины. В этом плане
sludge catcher device there, but it will not be able to clean the well properly. So that's why hydraulic tractors are better compared to electrical ones. Tractors can also be used to mill fracking ports. Hydraulic tractors are out of competition because we can select the optimal pressure, and with the optimal pressure, the tractor will mill the fracking ports. Acid treatments,
Открытие-закрытие сдвижных муфт. Здесь как раз
we can do acid treatments. We can open and close
части нашего гидравлического трактора
sleeves. You can use
закрытие сдвижного порта нашего изготовления.
This tractor to close the sliding port. You can see how it closes the sliding port. You can also use the tractor for opening of
Из-за того, что трактор может
sliding
передать
port.
значительное усилие, то это значительно
Since
облегчит
tractor
проведение
can
работ
generate considerable forces,
портов на забое.
it might simplify the works
Всё,
in
на
opening
этом
and
мы
closing
доклад
ports
закончим. Готов
at
ответить на
the
вопросы.
bottom hull. That's the end of my presentation.
Пожалуйста,
And I
вопросы
can
есть?
take your questions.
Ну тогда я.
Do we have any questions to the speaker? Then
Я
I will
понимаю, данный
ask
трактор
one.
предназначен для работы только в обсаженных колоннах.
Ну,
So this
пока да,
tractor
у
is
нас
meant for
мы
cased wells.
конкретного
Yes, so
Ну, я
far,
вижу по
yes.
площадкам, то есть в
Yeah, because I judge by the
работать не будет, то есть там
sites.
контактное напряжение превысит. и ты разложишь породу.
Здесь
because it won't be able to work in the open hole.
разрабатывали это сами. Сейчас
But
на
we
данный
can
момент у нас большинство работ
configure it
происходит в 114-х колоннах. Соответственно, мы
because
проектировали
the
под
majority of
114
jobs are
колонн.
done in
Перепроектировать сам
114
узел, то есть у
tubing.
нас уже
So we designed
все
it
есть
for
свое оборудование, мы
114
сами его
tubing.
проектируем.
But we have
Перепроектировать
all
под
the
открытый ствол,
equipment
но это просто
in-house,
удерживающее
so we can reconfigure it for the
нет
open
таких
hole.
действительно.
It's
Пока у меня
not
задача
so
под
difficult.
Я так понимаю, направление движения у него одно, в одну сторону.
And as far
Да, у него
as
направление движения
I
в одну
understand,
сторону.
it moves only into one direction. Yes, moves into one direction only.
Так, больше вопросов нет, тогда,
So we
Олег,
don't
спасибо
have any
за
further
интересный
questions.
доклад.
Thank you, Oleg, for a very interesting presentation.
Так, у нас следующий доклад опять в онлайне. Связь у нас есть.
And we will have next online presentation.
Выводите.
Good afternoon,
Сейчас,
colleagues.
минуточку, вас на экран выведут.
I'm here.
Да, связь у нас, похоже, есть. Следующий доклад делает Ирлан Исамбеков с Шлюмберже. Эффективная диагностика
So we'll
скважин
give the
для
floor
улучшения
to Lana
продуктивности.
Sambekov
Пожалуйста.
from Schlumberger, effective diagnostic of wells in order to optimize oil field development. I would like to thank the organizers of the conference for gathering us together. I would like to wish you good health in these COVID times. For me, it's a big pleasure to be present at this conference. I'm a technical expert at Schlumberger, and I have colleagues from Gazprom Neft and natural resource users from Gazprom Neft Yamal, Mr. Kosalapov and Mr. Virt and Mr. Komarov. So these are the co-authors of my presentation. So I'll describe the typical problems in wells that require diagnostic. We will speak about the importance of preparing a well for well surveying. We'll speak about the difficulty in doing well surveys. I will also show you why we selected certain solutions to certain problems. Speaking about the typical problems, they are not new. This is well yield reduction, increase in water cut. This is gas breakthrough, etc. Sand production. You can see all these main problems on the slide. There might be many, especially taking into account that the well completions are becoming more and more complicated. We have horizontal well bores with non-cemented liners, with filters and sleeves, and more sophisticated completions with the inflow control devices, etc. Whatever completion you have, one of the most important aspects is preparation of the well for the survey, because we need to survey the whole well bore, the whole horizontal section, and we face some blockages due to debris, etc. There's a need in milling ports and doing other preparations. So on this slide, you can see some analytical information, how we can prepare well with different methods. Of course, preparation with well workover is the best approach. You can clean out the well, mill all the ports, but each method has its own disadvantages and cons. So recently, well tractors are widely used. Our company also is using these well tractors. As the previous speaker mentioned, one of the difficulties that you encounter with tractors, if you have large amounts of propant or debris, then your tractor is not efficient. However, it might reduce the burden on the workover teams. What difficulties might we encounter when identifying the inflow profile in the small yield wells? Very often we have not a turbulent flow. There are some idling zones depending on well geometry. There is recirculation, especially in the heel of the well. And everything depends on the trajectory. I would like to show you a number of short videos. So these are the tests conducted in our research center in Cambridge. So the angle is 90 degrees, same content of diesel and water. And the dyes were used so that it is visible how the flow behaves. So the equal content of oil and gas. The speed is the same and phase distribution is also the same. And now the inclination is 88 degrees. You see what happens. The amount of oil and water is the same, but the lighter fluid takes smaller volume but moves at higher speed. So if we reverse the situation, then you can see a 92-degree inclination, and the heavier phase will take lower volume and will be moving on the bottom part of the tubing. With the angles from 20 to 80 degrees, here we have a 45-degree angle. We see that the heavy phase will be going up and falling down. This is recirculation effect that we call it. So that's why very often we can see water in well, but not all the water is produced to the surface. So our approach to identify the flow rate or well yield with the multi-phase flow, we need to identify the velocity of a phase, what is the shears of the phase, and we need to know the area. For this, we developed an integrated Fsi tool. The tool has 5 distributed flow rate meters, and 6 optical sensors and water content sensors. And it also measures the cross-section area. So the design of the tool allows it to stay in one position inside the tubing. This is the ideal case, 1/3. So each flow meter is located in its own phase. If we take the fully fledged flow meter, you will encounter problems because the flow meter will take different phases, and the rotation of this flow meter will not be able to correctly measure the debit, the yield of each of the phases. Together with Noyabrsk Geofysica and other companies, we were trying to select the optimal set of equipment to survey the wells. This is a map of tools to be used. There might be different ways of well stimulation. It might be compressing, and the delivery of the equipment might be done by a tractor or on a wire line, on a cable. And there might be advantages and disadvantages of each of the method. The ideal way of flow stimulation is the ESP, the bypass systems with the necessary diameter. We have such systems currently. And the well tractor, we selected for our operations the well tractor because CT with a cable injected is not always available, and we need to make quick decisions. And we have selected our Fsi tool and the noise meter, spectral noise meter, in order to check for the behind the casing flows, etc. Now I would like to give you a number of examples from real oil fields. Let's take well A. So at this well, we had a sharp increase in gas production, so we needed to understand what kind of gas is that. We conducted an integrated survey. You can see all the charts, part of the open hole, the distribution of phases, the spectral noise metering, and this is what our device has shown. So if we look at the horizontal wells, you need to put it horizontally, then you can easily see the change in the well profile and the phase distribution of fluids. So we identified the inflow profile. We analyzed the history of the well, and the survey data allowed us to make a conclusion that this is the lateral gas inflow along the reservoir on the wellbore. This well was drilled in a poorly studied section of the reservoir, and this new data that we received allowed to make further decisions about the production from this formation. In addition to this well, we analyzed data from the pilot wellbore, and interestingly, the formation is quite thin. We took samples, and we revealed that the vertical permeability, or the ratio, KV to KH, 0.7. So it's quite a good vertical permeability, unlike what we observe in the shoe part, in the lower part. So, and depending on this data, of course, taking it into account, you can design the layout of the wellbore and the behavior of the well in its different sections can also be taken into account in order to reduce this gas production. So another well, well B, injection well. To the left, you can see the open hole data, the noise metering results, and we had a hard landing near filter 2, and the decision was made to reduce the recording interval. But we observed a very interesting thing. This filter covers almost half of the liquid pumped, and the formation itself takes only 15% of the liquid injected, consumes. So we observed the sand screen out and reduced diameter for the liquid flow, since we have distributed flow meters. The upper flow meters were rotating, the bottom ones were not rotating. This again confirmed the geometry here. And for the client, they needed to clean the bottom hole area, and they also adapted the hydrodynamic model. Well C. So we needed to identify the inflow profile We identified all the phases. We identified the idling water in the heel of the well. And this data will be used for planning of further drilling in this well. And this is the last case, well D, injection well. And this example is very nice because we compared injection data from last year and this year. We compared the login data, whether the redistribution occurred or not. And yes, we revealed that there was a redistribution and injection. So the upper filters started to absorb more fluid. The lower ones started to absorb less. This shows the clogging of the middle filters here. So they planned some works to clean the bottom hole assembly, and the hydrodynamic model was adapted. The eastern Mesayaha field, well A, we needed to identify the reasons for high water cut, as the login data showed. So there's a water inflow through the cracks. Again, the client had to adapt the hydrodynamic model for this well. At the end, I would like to say that probably the cases presented by me show what kind of tasks you can tackle and resolve. And these solutions are very important, not only for individual wells. This information, this solution is also very important for planning further activities at the oil field. Moreover, as experience shows, you need to do service with the adapted technologies and software. And we showed our approach to this. And the survey program is adapted to individual wells and its conditions. So the preferable methods to deliver equipment is CT with cable or tractors to do online recording. So if you do it in autonomous mode, you will have some limitations in data recording. And it is also very important to properly prepare the well so that we can survey the whole interval and the whole length of the well bore. That's all from my side. If you have any questions, I can take them. Thank you, Yerlan. Questions? Do we have questions on the floor? No questions. Thank you, Yerlan. Wishing you all the success.
К следующему докладу. У нас их осталось 2 в этой сессии. Докладчик у нас Марченко Владимир Владимирович.
Now, I would like to give the floor to Vladimir Marchenko from Belarus-Neft, who will speak about the development of cluster fracking using plug-and-perf technology. Good afternoon, distinguished colleagues. I am Vladimir Marchenko. I am supervising fracturing activities in Belarus-Neft company, and today I would like to tell you about the history of fracking operations at our company and how we achieved the plug-and-perf technology, as well as I will speak about our plans for the near future. So we'll start with 2007, when we procured the fracturing fleet. Due to the specificity of our formations, these are carbonates, and our oil fields are quite mature. So we started doing acid fracturings, but they were not efficient because the reservoir pressures were quite low. That's why we started doing proppant-based fracking. It was quite successful. We conducted in different geological conditions and following different process schemes. We also upgraded the acid fracking technology. We inject propant plus acid, taking into account some geological conditions of our wells. And finally, we started conducting multi-stage frackings in non-conventional collectors with the bolt drop assemblies. And currently, we are using the cluster approach in cemented liners, including horizontal and sub-horizontal ones. With the development of fracking operations, we face certain problems like reduction in efficiency of our jobs. We updated fluids, introduced various technological approaches to improve the effect and boost the profitability of operations. However, we didn't manage to achieve the desired effect. And we decided that the quality of our wells for fracturing was very low. We had some pilot wells that were drilled in different directions that did not allow us to do high quality design of fracking. We had good results on the international arena, so it was not the poor design of fracking because there were audits conducted by the leading companies and we won prizes at various conferences. And low efficiency of fracking was due to the lack of accurate information. It started from the well design. So the decision was made at the company, if we want to perform high-quality frackings, including multi-stage fracking operations, we needed to improve the quality of well design and then ending up with running in all the proper tools. So first of all, the logging. So we needed to have a very good logging to check a well bore for maximum stress, so that we have it perpendicular to our well bores. We procured a number of modern well bore equipment. We did seismic frackings. We checked the cores to understand the geological conditions, and we identified the promising areas for well drilling. After that, we needed to ensure high quality of drilling, so we modernized our drilling rigs. So we procured only modern drilling rigs. We modernized our older drilling rigs, but for complicated geological and technical conditions, we did drilling with the backup. We modernized the downhole drilling equipment, so we're using a system with a hydraulic communication channel, or we use a rotary system in difficult geological conditions. We upgraded our cementing equipment and improved the quality of cementing. Our machinery allows preparing cement slurries on the go. So we also achieved certain achievements in developing our in-house cement slurries. We have our elastic cement slurries that are better than the foreign cement slurries, elastic ones that were used at our oil fields. The composition is quite difficult, but it enables us to put perforation clusters at a close distance to each other. We also needed to improve the quality of fixing and cementing the wells, so we use liners with the pressure differential at least 70 megapascals. So this year we started cementing with rotation-based cementing. You can see the quality of cement before the rotation method and our cementing with the use of rotation method. Summarizing this drilling part, we can make the following conclusions. Initially, we had mainly vertical wells. The horizontal parts were cased with non-cemented assemblies. Length of the wellbore was up to 400 meters. Now we improved the drilling velocity. We procured and rented modern equipment. We drill sub-horizontal wells to 3 stages for fracking, up to 1,100 meters of the horizontal wellbore with the rotary system. For the future, we plan to use the point-like drilling in order to increase the velocity and have extended reach of 1,500 meters and more. To conduct quick and high-quality fracking, we lacked specific equipment to close the intervals and perforating these intervals. So we procured some additional equipment for CT unit, for the logging unit, and for the tubing. So this modern equipment allows us setting plugs with a logging cable up to 8 clusters during one trip. We use our in-house setting equipment. So, and we plan to develop an innovative or procure an innovative perforation system from the West and the drill-out system. So we needed to tackle our fracking capacities. As the fracking fleet manufacturers mentioned, we had problems. The capacity is 7 to 8 cubic meters per minute. It's not enough because these are 2 perforations per stage. It's not enough if we want to move forward and increase the production from our wells. That's why, together with colleagues in quite a short period of time, 2-3 months, we established an integrated and single system collecting all the necessary data and information that would allow us to have up to 14 cubic meters per minute flow rate with the maximum proppant concentrations 1,400 kilos per cubic meter. Thanks to using 2 blenders in parallel. So we involved quite a large number of personnel for this operation, but if you put the fleet and mobilize the fleet properly, it works well. So this is our well number 67, bird-eye view. In parallel with the fracking fleet, our engineering center was working hard. Since 2007, we have been using guar-based fracking fluid with the cross-linker, but we updated it for different geological conditions, and we also created fracking fluid for plug and perf. This fluid allows doing frackings with small losses, friction losses, and quite good flow rates, up to 12 cubic meters per minute. So we have tested all the 3 types, the suspension, emulsion, and the powder type, 8 manufacturers, 20 types. So you can read an articles in SPE about this, and in 2021, we'll be using high viscosity fluids. And a few words about plug and perf. All our multi-stage frackings started in non-conventional reservoirs and formations. It was 2014, ball drop assembly, nothing interesting there. Then the same well, we refract this BHA by ourselves, so we developed the technology in-house. We injected a lot. The well was quite successful. I will tell a few words later. And we used plug-and perf at well for 111. These are unconventional collectors. You can read in more detail in our article in SPE. This is 310 well, 85 tons, first approach, classical technology, 2040, 1620 proppant, flow rates 3.5. The production was around 40 tons of oil. It worked for 1 year until 2019. In 2019, we did refracking, 6 stages, each stage 2 proppant stages. With the microseismic studies, 300 tons of proppant with the maximum concentrations 400, 500, and the well was put into operation with better parameters when at the very start. It is operating for more than 1 year already with very good productivity and yields. Well, it shows that in 2014 we were not ready for this multi-stage fracking, and then in 2019 it was okay, and our well 411 in Rechica, a pilot well for plug and perf. We did 11 stages there. On this slide you can see stage 8, 120 tons of proppant injected. We did microseismic studies at 9 stages. The well bore is in the proper direction. The fractures along the well bore shown by microseismic. We had a stop at the first fracking, and during the second fracking we had a fracture along the well bore. So these are standard conventional collectors with porosity of 12. These are classical collectors that we have. We did plug and perf on a cable. At 411 it was CT conveyed, it's cable conveyed plug and perf. We were washing every stage 1.5 to 2 hours for running 4 trips. We did 4 stages, around 400 tons of proppant injected, 2,000 cubic meters of the fracking fluid. And well 155, 7 stages, 3-4 clusters per stage, up to 12 cubic meters per minute flow rate, 120 tons of proppant max for stage. The 3,100 of fracking fluid. Currently, we did 3 multi-stage plug and perf operations. You can see the results on the screen, which is 40-50 tons of oil per day. It's quite okay for us, because the standard wells, which are sub-horizontal with multi-stage fracking, it's 8 to 10 tons per day, so we achieved quite good results. In order to do high quality plug and perf, we need to quickly normalize the bottom hull. We're testing now various screw motors and drill bits. We're updating the fluid to reduce time. Current drilling time is 20-30 minutes per plug, and we plan to reduce the time to 15 minutes with washout. And a few words about the upgrade of our fracking fleet. Thanks to our Belarusian colleagues, we did it very quickly. However, we faced a number of problems. The first is the limited flow rate, 14 injection, 14 cubic meter per minute injection flow rate and large area covered by the fleet on site. So we have the following plans. First, to buy a high-capacity blender and high-capacity chemical unit that would allow us to reduce the number of equipment units on site and ensure doing 7-8 clusters per stage. We also need a special tank for high viscosity fluids. The injection flow rate above 12 or 14 is definitely not for guar-based gels. And due to the legislation of our country, we are not allowed to put burns at every place, so we are planning to use vertical telescopic tanks to 300 cubic meters in volume, and they will allow us to reduce the area that we cover with the fleet almost twofold. So we are working in our engineering center. We procure 2 expensive units to our laboratory in order to identify the permeability of the propan pack and to identify friction losses. These tests will not only allow us to better do fracking in the standard formations, but will allow us to be more competitive in tenders. The main conclusion of my presentation is that in 2021, our company will be able to do high-quality plug-and-perf fracking, starting from well design and ending with a multi-stage cluster fracking, normalizing the bottom and running the downhole equipment on a turnkey basis. Thank you. Questions? Please take the mic.
Добрый день, Сидиков Сулейман, Газпромнефть, технологический.
I am Suleiman Sidikov from Gazprom Neft. Thank you for a very good presentation. Probably I missed it. So around 700 meters, the horizontal wellbore, yes? Or can you switch on this slide?
На текущий момент мы сделали опыт есть, скажем так, 11 стадий.
So, we have experience in doing 11 stages. Our plan for January is 12 stages, 3-4 clusters each stage. For May, we have a plan for 14 stages, up to 1,500 meters of horizontal wellbore, non-conventional collateral. So you don't have sanctions in Belarus? No, so far we don't have. So this data are for conventional or non-conventional formations? The wellbore length, etc.
За 1000 метров вести не планируем, ну, ввиду того, что нам не нужен такой огромный простимулированный объем.
So we don't plan to exceed 1,000 meters because we don't need this stimulated. 1,500 meters and more, this will be non-conventional. And you do CT conveyed milling. Yes, we'll do CT conveyed milling, and the first well was also milled with CT.
Были ли прецеденты, когда вы просто использовали растворимые пробки при...
Did you have any cases when you used soluble plugs?
Нет, растворимые пробки мы не использовали.
And packers, no, we didn't use soluble plugs.
Мы понимаем, ну, то есть, грубо говоря, использование растворимой пробки ограничивает нас во времени.
The use of soluble plug will limit us in time because we do some testing now. It's not feasible. We're using plugs with balls, and we drop the ball later.
Еще один момент.
It's clear.
Вы говорили, что закупили там геофизическое оборудование, это российское.
You mentioned procuring logging equipment. It's of your local production? No, it's not our equipment. And telescopic tanks, it was a new thing for me. Could you say a few words for us? So they're produced in the West, not in the East, not in the West.
Спасибо за интересный доклад.
Thank you for a very interesting presentation. If we don't have any further questions.
Итак, мы приближаемся к обеду, и на данный момент остался один последний доклад. Прочитает нам его Михалицын Егор Олегович, директор по развитию бизнеса Coiled Energy. Поведение растворимых сплавов и изделий из них в забойных условиях. Пожалуйста.
And the way they behave in bottom hole conditions. Yes, thank you, dear colleagues, for organizing and having this event. For us, it's a rare occasion because we mostly talk to the fracking community and to the completion community, and we actually do not often get in touch with the CT people. Last year we told you about our technology, and this year we're going to talk about the techniques and methods and details and the data that we got when studying how soluble alloys behave. I'll start to tell you about our mission. We tried to change the oil and gas industry for the better, because we always look back at our mission. So trying to find things that push and drive the industry. So we're going to speak more about technical things here, not about just commercials and corporate presentation. So I'll just use these 15 minutes to go to do a deep dive into the technology. So who are we? We produce soluble alloys. We have more than 100 proprietary alloys. We do them in chunks, in bowls, and balls. We do soluble plugs and plug-and-perfs, mills, pins, whatever. So everything that can you predictably put down the well and predictably dissolve over a projected time frame. I would like to tell you how our products behave in bottom hole conditions by using specific examples, by using a specific case of the frac job balls. So people are well familiar with these balls, but accumulating the experience of running these balls, we generate more and more in-depth knowledge and understanding of how soluble alloys behave. So let's look at the ball. So what is the multi-stage frag job ball? So how do you decide, how do you see whether the ball is soluble? They take a jar, just take 3% acid, heat it up to 90 degrees, and then see whether the ball gets dissolved or not. And they take it out and measure diameter once a while. Well, some get smaller quicker, some get smaller over a longer period of time, but eventually they all get dissolved. So usually you have a lot of pictures of different stages and measurements taken every 2 hours. And usually they produce a table to see how the ball diameter goes down. And it's good that it has a linear progression, and you can basically run the estimates of when the certain diameter will disappear. This is the picture that the customers usually seek and we produce. Unfortunately, in the industry, in our country, the approach has been like this. So we look at this picture. So we have a 70-millimeter ball. So what is the C? What is the saddle diameter? It's, for instance, 6 to 7. So we see that, okay, it will reach the saddle diameter over this time. Then there's also the minimum saddle diameter. In the CT completion string, that's usually the minimum tolerable saddle diameter. And looking at this chart, people usually think, okay, it takes 8 hours to dissolve to dissolve down to the settle size and then to the minimum settle size over the 45 years. And they relay this information to the field, and they think that they have 8 hours to do the frag job, and after that the ball will just fall down. And after 45 hours I will be able to just go down with the CT because all the balls will have dissolved by then. Unfortunately, this is how people treat these kind of data.
Даже вот, классическое буквально, наверное, неделю назад присылали одно из очередных требований.
Only recently, last week, I got a tender requirement that says that please indicate the time that it takes for the ball to dissolve down to the size that will enable its passing through the minimum settle size. 70 to 58 hours, 72 hours, and 100 hours. But what happens downhole? We've been working with soluble alloys for many years now, and we design test stand that emulates the bottom hole conditions. So we create hydraulic pressure, that is the approximate pressure of the bottom hole pressure. So we're looking at figures.
Стенд довольно сложный, потому что нужно постоянно менять жидкости, процесс растворения не такой простой, выделяется газ, его надо стравливать. В общем, стенд долго делали, но в целом такой стенд есть, и вот на нем мы начали ставить эксперименты. С чем мы столкнулись? В первую очередь вопрос, в чем же растворить шар? Если вы возьмете любой план работ по ГРП, то там вот обычно такая длинная табличка. Какие гели в какой последовательности будут качаться. Там есть линейные гели, сшитые гели.
Если поговорить linear gels, cross-linked gels. Some people believe that we need to be testing balls in the linear gel, and some believe that in cross-linked gels should be used. And depending on which gel you use, the ball will behave differently. We, as producers of also chemical agents for multi-stage frag jobs, have more in-depth knowledge because it seems that the situation is a bit more complicated. The same gel being produced using different agents will give you a different performance. Furthermore, the balls after the frag jobs, they dissolve much slower than usually on the test beds. We have gels that basically are unable to trigger the reaction. So I would tell that the realistic duration to expect is 5 to 6 times longer than the test figures. One of the charts here gives you how the ball dissolves in 3% chloric acid, and if you use gel, it just gets much longer to dissolve it. So how much impact does the hydrostatic pressure have? We've been mentioning the Fsi oil field today all the time, and we have requests coming there for 600 atm of bottom hole pressure. So if we're looking at the processes that run down under the pressure, the reaction gets much slower because hydrogen gets produced during the dissolution, and under the huge pressure, this process slows down physically. So if we're looking at 125 atm, this kind of pressure would slow down twice, and the greater the pressure, the slower the reaction. Furthermore, the important physical parameter is that if we have a ball sitting on the saddle, not just in a jar with chloric acid. So what happens? This is something that we told about in September at SP in October. Yeah. I would like to once again walk you through this. So we identified several zones. The A zone, the so-called cap, because the A zone is covered with fluid and it works quite well. Then we have the B and C zone. The C zone is actually the metal-to-metal contact patch, and there's no fluid there, so there's no solution there, so there's no reaction. Furthermore, there's also the B zone. B zone is the area of a slower reaction, and the B zone gets clogged with debris of the A zone that got dissolved previously. So what happens with the ball when it gets dissolved downhole? So it sits on its saddle, starts getting dissolved, and you see how it, you see that there's a certain sort of a skirt that remains intact halfway through the process. And if it goes further, they basically make a curtain out of this ball that shuts off the saddle, and it keeps. And after that, there's a pinhole that appears at the center of that screen of that curtain, which acts as a valve. And furthermore, this metal-to-metal patch gets much denser because there's the pressure, and the central part is easy to penetrate. So there's no such thing as the ball dropping out of its saddle. It never goes through its saddle, actually. And we cannot tell you exactly after how many hours the ball gets dissolved completely, because it does not get dissolved completely at all. So what happens is that you end up with sort of a screen there, like a curtain, and then with a pinhole in the middle that starts corroding. So basically, we produce this expectation and reality. So the expected time of connection between the frac job stages, which is supposed to be 8 hours, actually turns out that the real connection between the hydro frac stages happens after 370 hours, not 8. Furthermore, if the customer has an expectation that they base on the foundation of the conducted tests that the ball will drop through its saddle after 8 hours, in reality, it drops after 1800 hours. Which means that whenever customers think which alloy to choose, they usually opt out for the alloys that usually take much longer to dissolve downhole than people would expect. Because ultimately, they usually run into the balls that don't get dissolved at all. Because there are many factors that affect the reaction, and sometimes the reaction does not get triggered at all. This often happens when, for instance, there's some of the propant left downhole. So we believe that there is a saddle, and then the ball, then some propant tail, and etc. etc. So basically, there is some gel that gets stuck. Everything also happens at the bottom hole pressure, and after the CT goes down, it runs into balls sitting there one after another. So we came here to talk to you, CT people, to tell you that whenever you run into balls when putting down the CT string, it's probably because the alloy was originally chosen poorly. Because you could have opted for a more soluble alloy, but people are afraid that whenever they opt for faster soluble alloys, they expect them to dissolve in bottom hole conditions also really quickly, but they don't. Another important thing that only this year we really felt and that we tell you about, something that you need to consider, is that what happens with the ball when it's a bit dissolved and we end the frag job and drop the next ball, and then it isolates the next stage, and the former ball just sits there in its gel, getting gradually dissolved. So when we took 48 hours to dissolve the ball, it lost like 30% of its weight. And we decided to see actually how much pressure would it take to move it off its saddle from below. And it's magnesium alloy, and magnesium expands at a temperature much higher than the cast iron that the saddles are made of. So we drop the ball down when it's cold, it sits on its saddle, then it starts heating up, and then it gets welded in its saddle, and it takes 230 atm pressure to move it out of the saddle. And if we're using multi-stage sleeves that are supposed to be closed with CT keys, we usually make them in such a way that they are closed with 600 kg force. That would be about 8 to 10 ATM back pressure to close the sleeve. And we have a ball sitting there that would take 230 ATM to push out. So in most projects where we use multi-stage sleeves, and whenever we use balls that take much longer time to dissolve down a hole, there's rather high probability that most of these sleeves will just shut off by themselves if the lower reservoir will just communicate larger pressure. We believe that this is a problem in the area of the inability to choose the right alloy.
И это мы как бы на простых базовых изделиях шары, да. Все, что касается растворимых пробок плug-and-perf, растворимых равнопроходных систем.
So whatever whenever we mention plug-and-perf and soluble balls and pins and other soluble things, basically the same rules and the same reasoning applies. So the bottom line is that whenever you treat soluble alloys, you just need to treat them as, for instance, swelling packers, because you need to test them downhole in real conditions, in field conditions, and not apply lab results to run your projections. So whenever you need some consultations, just call us, write to us. We'll help you choose the right alloy for your jobs.
Спасибо за доклад. Вопросы, пожалуйста.
Thank you for your questions. Thank you for your presentation questions, please.
По видео был один вопрос для...
There was a question about video. Not to you.
Значит, Беларусьнефть спрашивали, значит, из какого материала сделаны шары, которые вы...
What they make their balls of, that you mill.
На ГНКТ.
That you mill out. It's their composite.
Надеюсь, ответ устроит.
Good. I hope that
у нас сейчас пауза, обед.
We now have lunch break.
Значит, прямо
and
налево ресторан.
We'll reconnect.
Сейчас у нас 25 минут, на обед у нас 35 минут. Поэтому в 15:00 к этому времени прошу подтягиваться сюда. Спасибо.